Welcome, guys. Happy Friday. Sorry I couldn't make it in. I wanted to start the day by just going over a little bit of the calendar again. Today we are on our surface area and volume notes of spheres. You'll notice when we come back on Monday, we have a one-day review of some of our formulas. I will be recapping these 2 days there. We'll be kind of freshening up a little bit on worksheet number 8 as well. But make sure to come in on Monday with any questions you have from worksheet 7 and worksheet 8 for me. I'd be happy to answer any of those for you. Let's, though, jump into our notes that we have to jump into, which those are not the right notes. Yes, they are. Sweet. So we're actually going to start on this page right here, page 18, for the surface area and volume of hemispheres and spheres. So these are considered ball-like shapes, if you want to think of it, any ball that has a flat surface that is rounded. And I'm just going to straight up give these to you because they're not ones that we'd probably know right off the top of our heads. But the surface area of an actual sphere is 4 pi r squared. And what's kind of cool about that is when we look at the shape itself, you can think of, like, even with a globe, that we have two hemispheres. And you can see that this top hemisphere right here is clearly half of the surface area that we have. So it's kind of cool to see that one of those spheres, or one of those hemispheres, I'm sorry, is really 2 pi r squared. It's almost 2 circles. You'll notice that's the area of a circle formula. We double it because we do have another one down here. That's where we got our 4 pi r squared from. Now, if you look right underneath it, a hemisphere is exactly 1/2 of a sphere, cutting it off. So a lot of times we look at this and we say, oh yeah, that means the surface area should technically be just half of what we see up here. If I cut that 4 in half, I end up with 2 pi r squared. But we have to remind ourselves that when I do that cutting, there is another surface that actually opens up, and that is the surface that looks like another circle. With this, we actually have to add one more equation of a circle into this. And my pen just died. Pause for 1 second. And I'm back. So when we look at this, we actually have to add one more pi r squared. So my surface area for this one actually weirdly looks like 3 pi r squared. And the radius, again, just to emphasize for you guys, is the distance from the center of your sphere out to any edge that you have. There's a ton of radii that I could draw inside there, so I'm not going to draw them all. For your formulas for your volumes, another formula that we probably would not know off the top of our heads unless someone gave it to us, it's actually 4/3 pi r cubed to find the volume. With volume, we remind ourselves that it's a little easier to calculate since we're just cutting something in half. We're not worrying about more surfaces being available. So in this case, your volume is exactly half of that. So half of that number 4 in the numerator gives me the number 2. You end up with 2/3 pi r cubed for the volume there. So those are going to be the major formulas that we use. Some of them are pretty straightforward when we want to utilize them. Some of them we have to kind of composite some shapes together and have a little bit of fun with. So let's just see a straightforward example really quickly. For number 1, if you want to try to draw a sphere, you are welcome to do so. It is a little difficult to do. I tend to start with a circle, and with Notability, they can give you that nice, that is not a circle, a nice looking hopeful circle. There we go. And then you just kind of draw another oval style ring around the middle. Just keep in mind that you technically can't see the back side of this, so we use some dotted lines to get that. That's about the best you can do with a sphere. I'm not grading you guys on your ability to draw these, just your ability to do the math. But they did give us that the radius of this was going to be 8 centimeters. We can now plug and chug into some of the formulas that we have up top here. I'll try to keep those in view for us so we can glance at them. But jumping into this problem now, if I wanted to find the surface area and volume, we could start with the surface area of a full sphere being 4 pi r squared. We plug in the number that we have for our radius, which is 8 squared. I believe that is 64. And remember, this is all multiplication when we don't see those symbols or those operations between the numbers and the characters. So we do just have 64 times 4, which should give us 256 pi units for this one. Since we're dealing with surface area, it is more of a two-dimensional flat surface when we look at that. What we can paint, that's going to be centimeters squared. Jumping into the volume of this one, we're going to use a similar formula that we saw up top. I can't quite squeeze it in. There we go. The volume will be 4/3 pi r cubed. Plugging and chugging that in here, that means that I've got 8 cubed, and these usually turn into some sort of calculator problems at the end of the day. So if you do 8 cubed and you multiply it by 4, you do get 2,048. I still haven't done the divided by 3, but the pi symbol is on the outside there. And honestly, that 2,048 is not perfectly divisible by 3. If you'd like to write the decimal, you are able to, but I like to leave things in reduced fraction form. Just don't forget your units like I was about to. With volume, we do have cubic units for this one. For problems like number 2, just be careful that your diameter is 10. That's really telling you that the radius is half of that value, which means that my radius is just 5 inches. That is then an exact duplicate of this problem going forwards. Hemispheres, let's toss one of those up here really quickly using our formulas. The surface area of a hemisphere, if you want to draw, I guess we could practice drawing these too. With a hemisphere, I actually start with the oval part of this. So I'll try and draw my best oval that I can. And then we just need to kind of draw the bottom of the bowl here, which I'm not very good at doing. Best I could do is that going forwards. We'll draw in our radius of 6 really quick. And we're back to plugging and chugging into our formulas. So if I can get those into view. My volume formula, let's start with surface area. I've got 3 pi r squared. Toss in what I know as my radius, which is 6. So we end up with, again, something similar to what we had earlier. You should get a final answer of just 108 pi, in this case, meters squared for surface area. For volume, we have our own little formula again. 2/3 pi r cubed. Plug in your radius of 6. More calculator problems very likely from this one. You would end up with a final answer of 144 pi meters cubed for that one. Number 4, the only difference that I give here, again, is you need the radius for spheres or hemispheres. It's the only measurement that you really need. I unfortunately did not give that to you. I only gave you the circumference. But knowing that the circumference is 2 pi r, we are able to figure out what that radius is really quickly. If I divide by, in this case, the 2 pi's, divide by 2 pi, those pi symbols are going to reduce from the left side. I'm just left with my radius. On the right side, the pi's disappear. 8 divided by 2 gives me an answer of 9. This one, not units, no units are given, so I would just say that your radius is 9 units. And from there, you're pretty much plugging and chugging the same exact things that you did earlier into your formulas. Let's jump down, though, to some of these composite shapes, because I think these are really worthwhile looking at. For the surface area and volume of this shape, I do want to point out that you cannot touch this little circle right here. This is why I gave you your formula for the hemisphere as technically 1/2 of the globe, if you didn't count the green thing. This is just 2 pi r squared for the surface area of that hemisphere. So we're not including that green disk that we see there. But again, break it down into your shapes. This is shape number 1. This is shape number 2. So the surface area of that particular shape, if I have 2 pi r squared, throw in your radius. You should just get 72 pi for the surface area of shape number 1. Surface area of shape number 2. This is a cone, so we would use either pi RL, or if I like to go to the old school, it's just 1/2 of the perimeter. Perimeter is 2 pi r times the slant height. Here is, you'll notice again that technically the 1/2 and the 2 reduce themselves out. So that's where that pi RL really comes from. And we will toss that in there. Pi radius is 6. They gave me the slant height, which you guys will notice is this measurement right here. Not the most fun measurement in the world to calculate, but at least they gave it to us. So I'm going to toss in a 2 square root 34. We end up with just 12 pi square root, actually, I should write this differently. 12 square root 34 is very likely the number that we have, and then pi comes after it. Those two values need to be added together. Unfortunately, although they do both have pi's, we cannot add numbers that have square roots with normal traditional numbers. So this is where your final answer actually becomes for the total surface area of 72 pi plus the 12 square root 34 pi. Don't forget your units for surface area, centimeters squared.